So section 13.3 talks about hyperbolas. And let's try and get a little bit of an intro into hyperbolas. So this is a graph of a hyperbola. This is kind of how you're going to graph it. The actual hyperbola is just the stuff that's in blue here. So it's two parabolas that face away from each other. These face left and right. You could also have hyperbolas that open up and down. But what we're going to do in order to graph this, we're not going to be plotting a lot of points. You're really only going to plot 2 points. Those points are going to be the vertices of your hyperbola. And we'll find these by first of all plotting 4 points that we would graph if this were an ellipse. And then we're going to draw this rectangle through those 4 points. Then we're going to draw the diagonals of that rectangle and finally use that as a guide to draw your hyperbolas. So it's actually a lot of work, but what happens is that it avoids us actually having to plot points. And plotting points just by hand would be really, really awful. So this is the way to go as far as graphing hyperbolas. Where would you see the shape of hyperbola? Well, a little farther south in Michigan. There's a nuclear cooling tower that you'll see near the Fermi plant. Nuclear cooling towers have a shape that's a hyperbola rotated around an axis. Before we had GPS, there was a system called LORAN, which was set up by a system of beacons scattered around the Earth and emitting signals at a regular rate. And finding the intersection of 2 hyperbolas allowed you to solve for where you were on the Earth. GPS is much better. If you're traveling faster than Mach 1, then behind you, you'll be leaving a sonic boom. In fact, Norman was down at River Days. I'm sure you saw the F-16s go by. They're roaring by. Now, that was subsonic. I couldn't imagine what the sound would be like if they were going at a speed above the speed of sound. It'd just be a deafening boom. In any case, that boom would intersect the ground and one branch of a hyperbola. And that's always been kind of a favorite picture. This is a plane at the moment that it breaks the sound barrier. So kind of cool. Where else? Well, you see it in architecture. Dulles Airport has a roof that's in the shape of one branch of a hyperbola. The Kobe Tower in Japan is also in the shape of a hyperbola rotated around an axis. I think there's one in Nashville, too, that's kind of like this. I'm not sure if this one's a hyperbola or not. Don't know. Be interesting to find out if that's a hyperbola shape as you roll your coin into a black hole. But let's practice graphing hyperbolas. So let me get back to this over here. A couple quick words about hyperbolas. First of all, some comments about their general shape. So x squared over a squared minus y squared over b squared equals 1. So if your hyperbola opens or looks like this, then it's going to be like the one we saw just a minute ago. It's going to open to the left and to the right. So opens left and right. On the other hand, if the y squared term is the positive term, you have y squared over a squared minus x squared over b squared equals 1. Because the y squared term is positive, this is going to open up and down. Cool. So those are the 2 possibilities that you're going to face in terms of graphing hyperbolas. Let's start with problem number 18. 3, I'm sorry, yeah, it's 13.3. So problem number 18, we've got x squared over 4 minus y squared over 4 equals 1. X squared over 4 minus y squared over 4 equals 1. Which way is this going to open? Left and right or up and down? Good, left and right. The x squared term is positive. I would suggest we rewrite this. What's the difference between this and an ellipse? How can I tell that I'm not dealing with an ellipse and I'm dealing with a hyperbola? The minus sign. Now, I got to give you a big heads up on this. This is a pretty epic failure if you graph a hyperbola as opposed to ellipse or vice versa. Make sure that you know that if there's a minus sign here, it's a hyperbola. And if there's a plus sign between these things, it's an ellipse. If it was an ellipse, we'd probably do this. We'd probably take and write it as x squared over 2 squared minus y squared over 2 squared again. And what would we do to find the vertices? We'd start at the origin, 0, 0. Go which way? Right 2 and left 2, and then up 2 and down 2. So you would do these points. You do left 2, right 2, up 2, and down 2. But because this is not not an ellipse, a hyperbola, instead of connecting these points, what you're going to do is you're going to draw a box. Now that box has already been drawn for you on this first one. So our next thing then is to draw the diagonals. So let's do that. The diagonals should go through the center, or at least pretty close to the center. If it's not going through the center of your box, then maybe you made a mistake in drawing the box. It should go pretty close through the center. I mean, cut yourself a little slack. I mean, we're not computers. Okay. Now your vertices are going to be on the edges of the box. So since this one opens left and right, it's going to look like this. And then another branch the other way. So taking my time a little bit more. Okay. So something like that. And that's it. There's your hyperbola. Yes?
When we're drawing the hyperbolas, do you want us to get them like really close to the x that we made through the box?
Yes. So a couple comments on that. And let me show you a couple places or a couple ways that you could, lose some credit on an exam. The reason we draw those lines is that those lines are asymptotes. So let me draw a couple more in here. Do this again. This is what I'm going to show you next is how not to draw a hyperbola. Some of the common mistakes that I see. So you're supposed to come close to these edges, in kind of a looping fashion. Well, people take it to an extreme, and sometimes they'll do this. And they'll just kind of trace along it, all right? That's frowned upon. Another thing that people will do is they'll come all the way to the center. Well, that's wrong too, because you're supposed to go to the vertex, and the vertex is going to be this point right here. One last mistake that I see people make is this. They come out here and then they ricochet off this as if it was a pool ball hitting the wall of a pool table, and they come out. What's supposed to happen is that you're supposed to get ever closer to this without really touching it. So it's supposed to get closer, and that's what this is. It's a guide. It's where your graph should go. So those are a couple of the ups and downs that I've seen on people graphing these things. As far as a test is concerned, I'd probably grade it like this. First of all, if you drew a hyperbola at all, probably got 2 points. If it opens the correct way, got another 2 points. And then the diagonals, the asymptotes, that's another 2 points. And then, miscellaneous, maybe 1 point. So about 7 points. If you're drawing an ellipse, there's just not much I can do in terms of partial credit. So please get that part right, because that's a catastrophic failure. All right, good question. Any other ones on problem number 18? Let's try problem number 24 next. So let's see that one here first. So 24 is 9x squared minus 4y squared equals 36. Suggestions. How would we start this one? Somebody said it? Yeah, divide everything by 36. So just like the ellipse that we dealt with in 13.2, we want a 1 on both sides, or a 1 on the right side. So that's going to give me x squared over 4 minus y squared over 9 equals 1. Mackenzie, what should I do from here? What did we do in the last one? Once we had the 1 on the right-hand side. So from here to here, we just rewrote this. Some help, maybe? So we'll write it as 2 squared and 3 squared. And what that does for us is it helps us decide where we're going to draw the box that's going to become part of our vertex. Or it's going to help us draw the asymptotes. So let's see here. Here's my equation. X squared over 2 squared. So I'll go to the left 2, to the right 2, up 3, and down 3, like that. And here's where we got to do a little bit something different. This is not an ellipse, it's a hyperbola. So what you're going to do is you're going to complete the square, or finish that rectangle. Here and there. I'll provide you graphs on your exam. So draw the diagonals. Kennedy, which way is this going to open? Left and right or up and down? Good, left and right. So it's a hyperbola in x squared, so it's going to open left and right. And let's see how we can do. Now, if you accidentally touch the line or something like that, that's fine. Just don't egregiously cross it or bounce off of it. These lines should be getting closer and closer to those diagonals, the asymptotes. So something like that. These looking okay so far? These first couple? All right. Let's try problem number 44. So 44 is 25y squared minus 16x squared equals 400. What should we do to start this one? Yeah, divide everything by 400. So let's do that. Divide everything by 400. So that gives me y squared over 16 minus x squared over 25 equals 1. Or better yet, y squared over 4 squared minus x squared over 5 squared equals 1. All right. It's not out of order. It's a different order. So what's the order here? Tell me about this hyperbola. Yeah, it opens up and down. Okay. Now I think this one will probably just barely fit on our graph, but it should fit. So see what you can do with that one. Finish graphing it. Yeah, that one goes up and down. We first have to draw that. Yeah, I'm thinking that the diagonals that I drew for you guys aren't in the right spot, are they? Okay. So in the y direction, I've got to move a distance of 4. So that'd be 1, 2, 3, 4 up and 4 down. This is going to open up and down. In the x direction, I'll move a distance of 5. So over here and then over here. Let's draw the rest of this box then. So here, there, and then finally the diagonals. So take some comfort that the diagonals seem to be going through the center pretty well. And last but not least, because this is a hyperbola in y squared, it's going to open up and down. So yeah, I think on the opposite side of the handout, the diagonals were drawn a little bit too narrow. So there we go. Say again. Why does it open up? It's a good question. Someone want to answer it? Why does it open up and down as opposed to left and right? No, it's all right. It's because the y term is the positive term. So if this opens up and down, something in x squared opens left and right. And that's what we started with back here. Okay. Let's try one last one. Problem number 28. So 28 looks like this. Y minus 2 squared over 4 minus x plus 1 squared over 1 equals 1. What's different about this one as opposed to, say, a couple of our previous ones? Yeah, the center. All right. So the center is no longer at the origin on this one. That's okay. First, before we decide where the center is exactly, let me rewrite this. How do you think I should rewrite this? 2 squared and 1 squared. Keep in mind that 1 squared is still 1, so we're okay there. Emily, what's the center here? Yeah, you got to be careful. 2 negative 1 is the way you read it, but if we wrote 2 negative 1, then it'd be opposite of what we need. We got to keep in mind that this is x and y. You know, something like that is only a point. You know, I'm not going to ding you too hard if you messed that one up. But the rest of this is going to look just like what we dealt with for some of our other problems. That is, we're going to move up 2, down 2, to the right 1, and to the left 1 to find the edges of our rectangle. So those, and hey, that's cool. We can use the x-axis as one of our lines. Rachel, which way is this going to open? Left and right or up and down? Up and down. Good. It's going to be kind of a narrow hyperbola. That's all right. I think they use hyperbolic lenses in certain instruments like telescopes and not cameras, I don't think, but maybe microscopes. Not sure about that latter one. But just like parabolas, they have a special point in them called a focus. And that has a lot of magical properties that we're not going to go into. Math magic, yeah. All right. How are we looking on problem 28? Or excuse me, actually it was 40, wasn't it? Oh, was that 28? All right. So problem 28. Do you want to do one more like that, or maybe problem number 40, or are we good on this? It's up to you. Bailey?
Like ellipses and stuff like that, where we had to put it into
Yes. So what I'll do is I'll give you separate problems. Some that'll be just complete the square, and others that I'll give you something like this at the very least, so it's already cleaned up, and then just have you graph it. But the reason I separate those problems is because if you can't complete the square, you still might be able to graph an ellipse, and I want to give you a chance to show me what you know. So I'm always very careful to separate those types of problems on my exams. All right. Anything else on this one? Do you want one more, or are you good? I don't have a consensus. No one would. All right. One last one then. Um, so that last one would be problem number 40. Yeah, use the backside. So this one is y plus 1 squared over 9. But instead of 9, what else could I write it as? 3 squared. Minus x minus 2 squared over 4, which is 2 squared. So start out by carefully determining the center. What would the center be, Lauren?
2.
Good. 2, negative 1. Two for x, negative 1 for y. Keep an eye on the scale here. So across the x-axis, that's units of 2. Every 4 little blocks is really a unit of 2, or 2 little blocks is a unit of 1. Krista, which way is this open? Good, up and down. Okay, so something like that one. For homework, try 17 through 29 and 37 through 45. I think this latter part includes some review problems.